Singular value decomposition, or SVD for short, can be used to compress LLMs. But applying it directly to raw model weights can severely degrade the output accuracy. The problem is that the SVD minimizes error in weights. But we care about error in outputs. To fix this, we can scale each input channel by how large its activations usually are. Then scale the truncated weight back down with the inverse. This is what the SVD method does. But there's still a problem. The method assumes input features are independent. When features are correlated, diagonal scaling isn't enough. We need a way to decorrelate the input features. One way to do this is via Kolsky decomposition. This approach is used in SVD plus and SVD LLM methods. Another approach is to use SVD itself to compute the whitening transform, as proposed in the second version of the SVD LLM method. Simply put, you run SVD twice, first to decorrelate the activations, then again to truncate the whitened weights. We are seeing an explosion of new compression methods right now. So I built this framework as a workbench to let you easily swap methods in and out, benchmark various combinations, and see what actually works.